Good morning, everybody, and welcome to Astronomy 100. Today is Tuesday, September
28th.
28th. Thank you very much. And we are actually in week 7. This week is important in terms of exams because this is the first time we're going to be doing the midterm. And there was a message that I sent this morning to some of you. Not everybody received the message. And those people who did not do the review, they must have received it. Those who did the review, they did not receive it, but it's still actually, they should be included. And let me explain what I'm talking about in here. The review itself has 2 points in it, 2 reasons why you really should do it, okay? The first reason, because it's a graded assignment, and it's not like an optional assignment. So you have to do it just because of that. So it's an assignment that you do, the grade goes toward your participation and involvement in the class. By the way, just before I continue any further, if there is a disruption in the internet, please do not leave. Wait for me to come back because I have had 2 problems in the morning already with the internet where it's stopped working and then I had to refresh my screen. So if that happened, please don't leave. Anyway, the point I'm trying to say about the midterm itself is it has a merit on its own because it's a graded assignment. It goes toward your participation grade, and it's important because of that. Not only that, but it has an incentive in it. You cannot score less than a perfect score in this assignment, no matter what you do. Let's say, for example, you take the review and you end up with, worst case scenario, let's say, for example, you ended up with 30 points out of 120. Okay, get 25% correct. I will go there and I will override it and give you full credit of 120 of 20. So there is that bonus, if you wish. So this is a free grade. All you have to do is just do it. Okay, you get 120 out of 100. This is a great offer. So I'm hoping that you guys need to take it just because of this reason. So this reason in itself is a good reason to take the review. If you don't do the review, of course, you're going to get a 0 mark on your participation. You really don't want that. It's a free grade. Take advantage of it. The other reason, and I think it's the main reason, is because it's really a review and preparation for the exam. So in other words, take it seriously. Because if you do well in it and if you prepare on it and you're confident in your review and your preparation, you should do well in the exam. And why does that matter? Because the exams, the midterms, have a lot of weight in your overall grade. So you would want to do that. You don't want to miss on this opportunity. I know some of you already did the review. And even if you did it and you missed the message this morning because of the fact that you did it, it's still a good idea to make sure you're at ease with every single aspect of that review. Because all of the units up to today, up to this week, were covered in that review. So that means that you are in confidence, you have confidence in the materials and you know exactly what you are doing. And come the midterm itself, you're going to basically fly through it, okay? And that's what I hope. Okay? So the point being in here is do the review, okay? Do the review because it's gonna help you in 2 ways. Make sure you get the grade for it, the full credit for it. No matter what happens, you're going to get 120 if you do it, of course. And then, because it helps you prepare your exam for midterm. And midterms have a lot of weight when it comes to your overall grade. So you'd want to do them and do them right, okay? So this is important point that I'm making it discussion item number 1 for today. Okay, so the discussion item for today is basically do. AD, can you turn? Okay, good, thank you. Do the review before Wednesday night. That's when it's due, actually, the review. Okay. So this is the item that I want you to make sure you post it as part of the discussion today. So this is item 1. No matter what happened, you're going to get full credit for it. So take care of it, do it at once, and be done with it. If you did it before and you still kind of shaky grounds on it, it's a good idea to do it again, because you can do it as many times as you want and still take. It's not going to hurt you if you take it a second time. Oh, I already got 120 points credit, so if I take it a second time, my grade might drop. It will not drop. It's going to stay where it was. Okay. But if you didn't take it, this is actually a good thing to do. Okay, so this is a free points that are basically anybody can grab them at ease. The only way you cannot get them is if you don't do it. So I'm hoping that you guys take advantage of that and prepare your exam, because this is going to end tomorrow night. By 11 p.m. tomorrow, the review will be over. Okay, and you cannot really do the review anymore. Okay, the actual exam is going to be available, the midterm that is going to be available Thursday morning, which brings me to another message that you have received from me yesterday morning, 7:30 in the morning, in that I myself will be on campus Thursday morning, all morning basically. And if you would want to meet, it's a good idea to meet, and in person, I can send you the details for it, but you really need to tell me ahead of time. I need to know by noon tomorrow if you're coming to in person and meet, and we can allocate a time and we go through whatever questions that you might have. So this is for Thursday morning. Thursday morning at 8 o'clock is when the actual midterm is going to be available. This is really when you should plan to take the midterm. You should not really plan for it on any other day. The midterm itself is due by Monday, but don't plan on working on it on Monday. Monday is too late. If you plan, it's a very, very bad plan actually if you do it on Monday. So plan on Thursday, prepare well for it, make sure you're confident in taking it, and that is the day when good plans are. This is actually takes you to another thing in here, which is anytime you're given an assignment, not necessarily in this class or any class as a learning, good learning skill, is to actually start your assignment early, no matter how basically you have other things going and other things happening. The assignments, you really, whenever it's open, that is the plan. That is when you should work on it. Okay. For this midterm, Thursday is the day when you really, really should plan working on this midterm. Okay. If you cannot, for some reason, do it on Thursday, you have Friday. It's not really ideal, but it's better than nothing. So at least you plan on Friday. If for some reason those 2 days basically have absolutely not, you cannot do your midterm on, then that is Saturday. Saturday is the day when you're going to sit down and take your midterm. Do not plan on any other day outside of this 3. Ideally, it's Thursday. As a backup plan, you can plan for it up to Friday or Saturday. Do not plan or think that it's going to happen on Sunday. Sunday is very bad planning. Do not do that. That is actually, yes, you have that option, but don't plan on working on it on Sunday. The worst plan, the disaster plan, the terrible plan is to plan on Monday, actually, the last day when it's due, because that's the day when all kinds of things go wrong, okay? That is the day when you will have problems probably with the power. That is the day when you'll have probably problems with the internet, like that happened to me already in the morning twice in here, okay? So there will be a disruption, and Canvas doesn't care if it's an internet outage or something. It's going to submit it on your behalf. And that is really not good. That is the day when probably the computer has issues. For some reason, it's too slow or too buggy or something like that. That is the day when actually the bosses will call you and tell you that you have to show to work and you cannot basically miss a minute of the day because we have an important client we have to take care of. That is the day when family matters become urgent and somebody needs to be taken to the hospital and you have to be there to help them with whatever you need to help them with. That is the day when the car probably has issues where you have to take it to the mechanic or go and pick it up from the mechanic. Otherwise, they're going to be charged extra. So in other words, don't plan for Monday. It's terrible plans, okay? For any assignment, don't leave it to the last day. Plan for it early on. So again, the midterm is going to be available on Thursday morning at 8 o'clock. You have exactly 85 minutes to complete the actual exam. And it's planned to spend about 1 minute and 25 seconds per question, basically. And built in into that, there is actually about 15 minutes to review all of your questions and go through about it. So if you plan correctly and you do it right and you do the review and you're at ease with it, this should not really be an issue. About an hour and a half on Thursday, take care of it, and that's it, and you're done. It's behind you. Now you focus on other things, other classes, other things, where the assignments also are supposed to be due and taken care of in due time, okay? So this is the whole idea about the two messages, one of them that you received yesterday, but the main thing, the message that I sent today concerning this one. The reason why I'm making a big fuss over it is because the midterm is really, the midterms in general are extremely important, and I really want you to focus on these things. So let me share with you the screen to see exactly what we have this week. Okay. Of course, you can always post to the chat. Does everybody see? I know a couple of you came in late. What I posted on the chat? If you did not, please let me know. If you did, then ignore this request. Okay. So it seems like that everybody's on board. So again, this is basically how this week looked like from the vantage point of a student. So I'm looking at it as a student. So week 7, we have the materials that are covered in here. And this is what I was talking about. This is the midterm review that I'm talking about in here. So this is the thing that you are going to be doing. It's going to expire tomorrow, September 29th at 11 p.m. So you really need to take care of this as soon as possible. This is the midterm that is going to be due on Monday, October the 4th, but it's going to be available on Thursday, Thursday, September 30th, okay, at 8 o'clock. So this is the actual exam. And this is basically the stuff that we came accustomed to. So this is the review from the previous week, some of the highlights from the last week, of course, all of the discussion, everything else from last week is there. The objectives from this week are here. The recording of this session, when it's done, I'm going to post it in here along with the discussion items. One of them is the one I already mentioned, is to do the review. And we have something else that we need to talk about. We have a project, actually, that we need to talk about, okay? I'm going to briefly introduce that today. Promise that I will come back to it with more detail in the future to understand what we're doing in here. So let me open the objectives for the week. Of course, I'm looking at it as a student. Guess what? Item 1 has to do with exactly what I was talking about, okay? Item 1 has to do with exactly what I was talking about, and that is to do the review and make sure you finish the review on time and you actually do the exam, which is going to be available this Thursday at 8 o'clock in the morning, and it's going to be due Monday, October 4th. So this is basically what I've been talking about. Item 2 is the topic that is covered this week. Unit 39 is not included in this midterm. So it's part of the next midterm. Doesn't mean that we skip it, but it is something that we're in the midterm, we're covering up to unit 38 from last week and before, okay? So from weeks 1 to week 6. So that is midterm 1, okay? So anything during those times is going to be covered in midterm 1. And then anything from this point on is going to be in the next midterm. Doesn't mean that we have to ignore it because it has its own weight and its own merit. This week, as I was saying, the focus is on the midterm. That's why we don't have any homework. That's why we don't have any quizzes. That's why we don't have anything. And the project you will see is actually not going to be available until next week. Okay, so let's talk about the unit for this week, and then we're going to jump into the project and then answer any of the questions that you might have. So the topic of the day for Unit 39 is the moon. The Earth's moon, that is, because there are a bunch of moons in the solar system, a lot of them, okay? And all the outer planets have moons, namely Jupiter, Saturn, Uranus, and Neptune. So if we don't find a planet without moon from the outer planets, we have to question why. Because everybody has moons, including even the dwarf planets, they have moons, okay? Pluto, for example, has 5. So if somebody doesn't have a moon from the outer planets, we should really question why. We should try to understand why in the world they don't have planets. Inner planets do not have moon. So if somebody has a moon from the inner planets, we have to ask why. Case in point, the Earth. Earth has moon, not just a moon, but it's a big moon. So we really need to understand why in the world the Earth has moon. So that is a question that we need to address. Because if we look at Venus, for example, and Mercury, they don't have moons. Venus is the same size of the Earth, and it does not have a moon. Mercury, which is a lot smaller, it still does not have a moon. Mars has a couple of asteroids that basically it captured a few miles across, and they are not really any sizable significance, first of all. Second, they are actually, their composition and chemical composition is different, so they are actually captured, and we can understand that, okay? But when it comes to sizes of the moon and composition, the moon is the Earth's moon is an odd object that we really need to understand how it came to be that the Earth has a moon. For one thing, the density of the moon is 3.3 grams per cubic centimeter. The Earth's density, which is the most dense object in the solar system, is 5.5 grams per cubic centimeter, which means that the composition is slightly different than that of the Earth. It's not similar. There are some similarities and there are some differences. For one thing, it looks like the moon is not as rich as the Earth in terms of iron. So that's what has an extremely high density that brings the density higher. So the moon is kind of an odd when it comes to this numbers. Furthermore, it has different compositions than the Earth, and it also has some similarity in terms of potassium and some other elements. So we needed to understand that. So for that, there were some models trying to understand it. One of the models is the moon, must have been a planet on its own. It's a big object, by the way, the moon. It's bigger than Pluto itself, which is a dwarf planet. So the moon, which is a big rock, big astronomical object around the Earth, the theory says in here is that it could have been a planet on its own, orbiting the sun as much as the Earth does. But it was in the vicinity of the Earth that the Earth captured it due to gravity, and then it became its own. So it basically owned it. And there are cases like this one in the solar system. However, there is a problem with this theory in terms of the composition. Some of the elements, they're identical actually between the Earth and the moon. So this is not good because of the fact that at some point they must have interacted to have this common elements between them. So this is not good. This is not really a good theory to work with. The other theory is that maybe the moon was part of the Earth in its early formation, and because the Earth was spinning so fast, part of it basically spun out, and that explains the common elements. Now we have a problem. The densities are not similar. There are some differences still. So that is not a good actually explanation too. Another explanation is that it must have formed out of the same basically elements, of the same basically materials, but because it was too close, so it stayed in its orbit around the Earth, so they formed in the same time. First of all, the age of the rocks on the moon is not exactly the same age as the Earth. Even the oldest ones are slightly younger than the Earth. So it must have formed later on, okay? Or if whatever causes formed a little later than the Earth. So there is a problem with that approach, and The other thing also is that it does not have the same, because if they formed out of the same basically materials, it should have identical also densities, it should have the same amount of iron. So there is a problem with that theory. Well, the other explanation is to explain part of the materials from the Earth, part of the materials not from the Earth, is that maybe there was another planet, a Mars-sized planet, according to the models basically that the calculations and the simulations, that formed in the same neighborhood of the Earth. So we're back into the first idea. And that planet most likely was actually on the same orbit with the Earth. They were moving in the same orbit, basically 1 astronomical unit from the sun. But because of their proximity, they collided. So now we have that contact that explains the common materials, and we have the origins that are different to explain the differences. But because of that collision, scattered most of the materials from the crust of the Earth and actually left bit of the mantle. We have those materials from the Earth, and that explains a lot of things. Some other things, among other things, to explain in terms of the composition, of course, and among other things, that explains a modern observation of something that was not accounted for when the theory was proposed, and that is there is an asymmetry in terms of the actually inner core of the Earth, and that asymmetry could be from the differentiation, basically the material from that collision going all the way deep to the core of the Earth and causing that asymmetry. So that could explain that, and that could explain the changes in the magnetic pole actually of the Earth. So there is that came in from that. So it explains the composition that was proposed initially, and then it predicts something that was not part of the theory. The other thing also that it came out, and that's actually very good for the model, is the fact that, and again, we're talking about how the moon moves around the Earth now, is that all the planets, for the most part, okay, orbit on the same plane. If there is an exception back up and down, it's because of some things that we can explain due to later events like collisions or other events or influence of gravity of another object or something. So for the most, they're on the same plane, and the plane is called the ecliptic, okay? And we talked about that when it's coming from the conservation of the angular momentum as a vector. The Earth is tilted. If this is the equator of the Earth, and this is the ecliptic, the angle between them is 23.5 degrees, okay? So we know that. And that's what causes the seasons of the Earth. So in this case, the pole, the North Pole, is perpendicular. It's in here. So this is the equator, and this is the ecliptic. The moon then has another thing, another property in here. It does not orbit exactly on the equator of the Earth. It does not orbit exactly on the ecliptic, but it actually crosses back and forth with a difference of angles of between 18 and 29 degrees. If we do the model of a planet, Mars-sized planet, basically hitting the Earth, that fits perfectly with it, if it hits it to the right angle with the right speed, okay? Not only it forms the moon, but it also gives you those numbers. So it seems like the model is beautifully matching. The planet actually has a name now. They call it Theia, okay? So this is basically how we arrived into a lot of these conclusions about the structure of how the moon came out to be. Again, it's an odd thing, and we need to understand how come Earth has this moon, okay? So this is basically the leading theory. Obviously, what I'm talking about in here is not a substitute for what you need to do to read this unit. Please focus on the exam, as the discussion item already went by, and then make sure you read the unit also in full detail to make sure you get all of the nice details about the process into which how the moon formed, okay? Well, because again of the fact that moon now is close by the Earth, it's only about 380,000 kilometers from the Earth, which is really slightly over a minute in terms of light. If you shine a laser beam, it's going to take slightly then second, I'm sorry, did I say a minute? Slightly more than a second to, because the light does 300,000 kilometers per second, and this is 380,000 kilometers. So it's slightly more than a second to reach the moon. So it's very close by, okay? It's gravitationally locked with the Earth. In other words, they're too close And this causes the moon to spin around the Earth in about 30 days. That's the lunar month. And spins around its axis in about 30 days also, which is a lunar day on the moon. It takes a long time. So if you happen to live on the moon, or if there is a mission on the moon, you will have about 15 days basically of daytime and 15 days of nighttime, okay? Because of the fact that it's spinning extremely slow around its axis. So because of that extreme slow motion, one of the projects that some of my former students in another college were working on basically a lunar mission, and one of it is to basically have a rover moving on the moon, and the rover uses, of course, solar panels to power its own internal machinery. But then there is a problem with this exposure to the sun, because you will have many days before you get the sun back basically hitting the rays. Anyway, this is an extremely slow motion on a day, and then because of this tidal locking, it's always facing the Earth with the same face. Which one ended up with? It's a 50-50 chance this is the one we're looking at the moon when we look at it day in, day out. It's obvious when you look at the moon from your naked eye, basically you don't really need anything at all, that the moon has dark regions and bright regions. These are the highlands, and these are the lowlands, called maria, plural of mare, okay, which means seas. Maria, seas. It's actually Latin, okay. I don't know how it is in Spanish, but I know what the word in French is mer, so it's not too far from it, okay. So these are lowlands. The color distinction here has to do mainly with the composition. This is mainly basaltic rock, and this is mainly basically different kind of rocks, and including some minerals in it, and namely aluminum and other minerals in it. So, and these are highlands, meaning exposed to the sun, and this is the lowlands that I was talking about. So this is the main difference in terms of the side of the moon that we see. The other side is not too different from this one. Actually, there is a slightly difference in terms of distribution, but it still has this similar features, if you wish, okay? Both of them are marked with craters. With the exception of the craters are far more dense in the bright region, or the highlands, and sparse in the lowlands. Why is that? Was the impacts that hit the moon were hitting it more on the highlands and not on the lowlands? Not true. It hit it in the same proportions every which way. The moon does not have an atmosphere. Even the small rocks will cause craters, okay, on it. Even the tiny ones, a few centimeters one, will cause craters. And the craters, they vary in size from few centimeters to a few dozen kilometers. So basically some hundreds of kilometers. So the craters and the impacts in it, depending on the size of the rock that hit them. And that's the other feature of the surface of the moon, is that it has a lot of craters, as I was saying, and craters are far more dense, meaning it's denser, meaning that they're closer in these regions than in this ones. So what happened in this case? It seems like some geological activity in the past, which explains the structure, which is basically which is resulting from the lava flows that covered a lot of those craters. So that indicates some geological history of the moon, or what happened to it. Now, the craters that came later on basically left, or the impact that came later on, they left craters as we see in here. A lot of them are scattered every which way. I mean, you can see a few dots in here. Those are big craters, by the way. This is the entire surface of the moon. The moon is about a third of the diameter than that of the Earth. Okay? The Earth is 12,000 kilometers. You're looking at about what, 4,000 kilometers across in here. So this is, so the perimeter is much bigger. Of course, you multiply that by pi, okay, to find the entire perimeter. Anyway, so these distances are big distances. They are not small distances. The other feature that you can see is this lines in here, which are called rays. And these craters in here, this one actually is the Tycho crater. indicates that there was actually some lava flow in the past, and that is basically the volcanic activity in the past of the moon. So we have a lot of things that we can tell just by looking at the surface of the moon, and it tells us that early on, when the solar system formed, there was a lot of leftover debris from that formation, and that fell every which way, basically due to the force of gravity. It collided with several objects in the solar system, and this is the signature of that. As a matter of fact, this is used to date how old the surface is, because the moon was active only for a short period of time, and then basically it stopped from its activity. So it left a footprint of that activity on the moon. As a matter of fact, if we look at Mercury, we see similar features. So Mercury also went through a very quick geological activity, and then after that, it left a lot of those impacts. If we look at Ganymede, if we look at Callisto, the moons of Jupiter, also we see these features in here, indicating that whatever activity that was early on and all of the impact, they left their footprints in here. If we look at some features, for example, if we look at the moon Io on next to Jupiter, or look at the surface, for example, of Venus, we'll see a lot less of these activities in here, indicating that the surface itself is being regenerated all the time. So that means that there is actually geological activities going on those surfaces, like the Earth, for example, too. So this is basically the surface of the moon and the different features that you can see on it. In terms of internal structure, I mean, we can model it over the Earth, but there is actually another advantage that we were able to take advantage of, and that is the fact that the moon has quakes on its surface. It has moon quakes, not earthquakes. Okay, as opposed to Mars quakes or earthquakes, we have moon quakes on the moon. So what causes them? Most likely, the tidal forces, because it's tidally locked with the Earth, is the one that causes them. Okay, let me explain what that is. Remember, the Earth has two tides, low tides and high tides, twice a day, twice in every 24 hours, I should say. Because the Earth has a liquid surface, so you can see it easily on the liquid surface, on the oceans, for example, the low tides and the high tides, you can see them very easily. Whereas on the moon, we don't have any water. There is no liquid water, there is no air, there is nothing. So in this case, its surface itself is actually being stretched one way or the other by the Earth, just as much as the moon is stretching the Earth, because of this interaction between the two. This causes the internal structure of the moon to move, and that causes moon quakes. Okay, it's like you need the dough, for example. Okay, work it out. So the inside is actually getting warmer. Of course, for the dough, you don't feel it, it's a small quantity, but for the moon, albeit it's small quantity, but it adds up and causes a lot of basically release of energy in the form of quakes. So that gave us an indication of the structure of the inner of the moon. So right now, the best models for the structure of the moon itself is that you have a crust, you have a big mantle, actually, relatively speaking, is a lot bigger than that of the Earth, but in relationship, not in actual size. The mantle of the Earth is still bigger. But you have a smaller core now. The core has the outer core, which is melted, and it's not necessarily all iron. It's actually iron silicate, okay, which is some sort of a chemical compounds that involve silicium and iron. And also, you have a hard core, you have actually solid core, which is still iron and nickel in it. But it's because it does not have a lot of it, and it does not have radioactivity, it does not really generate a magnetic field. So the moon does not have a magnetic field, does not have an atmosphere, does not have liquid water on its surface. Probably on the caps, there is some ice that was discovered in the past. And it has, these are the main features of the moon. In terms of density, as I was saying, it's 3.3 grams per cubic centimeter versus that of the Earth, which is of a higher density than the moon, okay? So this is in a nutshell, basically the different things that we have about the moon and its history and its composition and its importance and things like that. So we can do a lot with the moon. As a matter of fact, the craters themselves are used to date now other things. The highlands are much older than the lowlands or the Maria. their age between, what is it, 4.1 to 4.4 billion years, according to radioactive dating. And whereas these surfaces are in here, they can go as far as 3.9 billion years. So that means they have been reworked by the geological activity that existed in the past on the surface of the moon. Right now, the moon does not have any geological activity other than these minor things that I was talking about in terms of moonquakes. Okay. So these are the main things in terms of this unit. This is not a substitute for what you guys have to do, which is reading this unit, which hopefully you're going to do immediately after you take care of your exam, which is this Thursday. And then let's go back into the home in here to see what we have this week. So we talked about this unit. I made a big fuss over the midterm. I know a couple of you came in late. And for those who came in late, the item of the discussion so far, I'm going to copy it and paste it again. So if you didn't see it, is to do the review. Okay? Make sure you do the review. And the review is from last week, and the actual midterm is going to be available this Thursday, September 30th. Okay. Then, in addition to all of this, we have this item in here. I'm logged in as a student, so I'm going to see what's going on with this thing. It's a project. So let me open a project and see what's going on. So I'm going to open it to say, can do that. And it does not give me any details. In terms of the actual project, it says this assignment is locked until October 4th at 8 a.m. So even if I wanted to do it now, I can't. I have to wait until that day. Okay? And that's in purpose. I did it in purpose so that you guys can focus on the exam, take care of it, and then come back and we'll start working on the review. But from the get-go, you see this thing, the rubric. So what is a rubric? In here, a rubric is how am I going to grade your assignment. Actually, you could grade it yourself. You don't need me to grade it for you. All you have to do is take this rubric and apply it to your project. Did I do all of these things that you did ask me to do? If I did, then I should get these points. If I didn't do that, but did this, rather I get this many points. If I didn't do any of that, this is how much I should get for this part. And then I move on. Question 1, okay? I will get this many points if I do all of this, okay? If not, I get no points at all. And so on and so forth. I can go step by step in here and I can grade myself. I don't even need somebody else to grade me, including all the way to the conclusion. So you know exactly how you're going to be graded. Which means that while you're doing your report for this project, it's a good idea to have the rubric in front of you and also the report as you're working on it. It says, do this one, let's do that one. It says, do this one, let's do this one, and so on and so forth. So it's a good idea to have them both side by side so that you're looking at it and working on your project, okay? So that you don't miss a thing. Did I do this? Check mark, I did, good. Did I do the second item? Look in here, yeah, I did, check mark, okay? And so on and so forth until I complete all of them and I have all of them checked and I did them the way that they are supposed to be. Then in this case, I'm in good shape. I did everything I'm supposed to be doing. So the rubric is a good point to keep in mind when you have assignments of this type, to make sure you know exactly what is expected from you and you do it exactly to the perfection so that you get the entire full credit for it. No questions asked. Now, if there is issues, you will see my comments and you will see how you're going to, what happened in there. So hopefully you can address them in the next assignment, okay? Now, meanwhile, when you have difficulty with something or you don't understand something, please let me know. I don't see this right now as a student, but because I want you guys to really have a feel of what projects look like, I'm going to leave the student with you and I'm going to see it as an instructor, of course. And as a instructor, it allows me, of course, to see this. Among other things, I can edit it, but I don't want to edit it because I think everything is right. And so this is basically in a nutshell what the instructions are, okay? It has 2 links actually in it, 2 links. I can click here and it takes me to somewhere, and I can click here and it's a PDF file. But the second link has this verb attached to it, may, which means it's optional. You don't have to. What is the purpose of the second link? Is to help you submit the report. Okay. If you want to do the report, you have two options, really. One option is to actually use this PDF file. Second option is not to use this PDF file and use whatever you want to. Okay. The reason why you don't want to use the PDF file is, for example, it does not work for you. You try to open it, it does not open. You try to put stuff in it, it does not write. You try to save it, it does not save. So it's not the way that you want it, or you don't even like it. You don't like the way it's laid out. You would want to write your own report. So in this case, you open your favorite editor like Word or whatever you want to work with, or text or whatever format you want, and then you start writing. Keep in mind the rubric in that case. Keep in mind that you're going to be graded on these things. You have to make sure that you're going to address them in this order with these names. The reason why the order is good is because it helps me when I'm grading them, so that I don't have to skip to item this one and then come back in here. So keep the order. That's important. Other than that, you can make your own reports. You don't have to stick to this PDF file. Now, if you want to, you can still use it because you have the option to do so. So the second link, we're done with it. The first link is actually where all the thing is happening. So I really need to click on it. I'm going to click on it. It takes me to this page. There's a bunch of things that I have to read in here. And there are several units from before that you really have to look at. So you're going to look at those from the units. Actually, this serves as a review for the exam too, because I know the retrograde motion is part of the exam. And one of you already sent me a message concerning that. So this is actually a good way also to do that. So that's why actually one of the reasons why I opened it to begin with is because one of you sent me a message. I was not planning on getting this intro to it, but the reason why I'm doing it is because one of you already sent a message, and I know it was part of the units that we covered up to this point. It's part of the exam, by the way. But it's not in this form. The book gave you about a paragraph talking about it and gave you these two pictures basically explaining them a little bit and moved on. But in here, it has more data in it from the years 2005 and 2006. And this data, you're supposed to plot it on the graph. And we're going to talk about this one in detail. So do not start on it right away, okay? You have your midterm to worry about, okay? And then it has this data in the table in here. The title of the project is the retrograde motion of Mars, okay? But actually, it's not just Mars that we're worried about. It's Mars, Mercury, Venus, Jupiter, and Saturn. Those are planets. And also this dwarf planet Ceres, which is part of the asteroid belt between Mars and Jupiter. So we have all of this object that we need to track them, because initially, when we looked at the objects in the sky, we saw them, they all move in one direction. They all move from east to west. With the exception of Mars, it does move sometimes back toward the east while it's moving back toward the west. So it's going west, and then all of a sudden, oops, it goes back toward the east and then continues toward the west. So that is what we mean by retrograde motion of Mars, okay? It turns out modern observations, not just Mars that does it. Venus does it also with a big deal too. But the other objects also do it. All of the planetary things, if you really think about it, they do that. So we wanted to understand that. So the early, basically, observers of the sky, they came up with a model. Ptolemy came up with a model of basically that, everything is revolving around the Earth. The Earth is the center of everything, and this is the geocentric model. Everything revolves around the Earth in circle. In order to explain the retrograde motion of Mars, he proposed that Mars basically moves in a circle, and that circle, the center of that circle, moves in a circle around the Earth. So the circle in here right now in position 2, this is where Mars is. In position 1, the center of the circle is somewhere in here on this circle. So it's like this, circle like this one. In position 3, the circle is somewhere in here. The center of the circle is somewhere in here. So this is actually where the circle is. So there are a bunch of circles I'm not drawing in here, but each time Mars moves. In position 4, probably the center of the circle is here. So that this is 4. In position 5, probably the center of the circle is here. and so on and so forth. In position 6, the center is exactly opposite. So it's going to be here. In position 7, the center would have moved in here and so on and so forth. But that's the center of the circle. The actual position of the planet is positions 1, 2, 3, 4, 5, 6, 7, 8, and all the way to 11. So if I'm interested to draw these positions in here, and I'm looking at Mars, all I have to do is draw a line. Take a line from the Earth and connect it with 1. This is how it appears in the background night sky versus the stars in the night. So it appears in here. If it's in position 2, I'm going to take another line connected from the Earth to position 2 and project it on the screen. This is position 2, how it looks to me versus the background night, but it's how it looks for the stars. So initially it was here in position 1, now in position 2 it's somewhere in here. Position 3, again, I take a line and draw it, and it's in here. So here is how the story looks like to me. It was in 1, it moved to 2, now it's in position 3. So it's moving nicely from east to west like everybody else. Now in position 4, it has moved to this position. So nicely I have 1, 2, 3, and 4. Everything looks good. Position 5 though, if I project it, it's going to be less than 4. It has moved backward. Position 6, it has moved even backward. So remember, 4 was here, 5 is here, 6 is back in here. Okay. Position 7, it has moved even down. Okay. So it was 1, 2, 3, 4, 5, 6, 7 now. Position 8, it has slightly moved in the same direction. Actually, it's now moving forward. Position 9, it has moved toward where it was actually just below where it was in position 4. Position 10, it's way outside of position 4, and position 11. So if I draw lines in here from the Earth to all of these positions, I'm going to find 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So that explains the retrograde motion of Mars. This is the geocentric model, where the Earth is the center of the solar system. Obviously, this is wrong because of other reasons, not just necessarily the retrograde motion, but because of other calculations and other observations. This is the correct picture. The sun is actually the center of the solar system. The Earth is going around the sun, and so does Mars. Both of them are going around the sun, with the exception that the Earth is going a lot faster than Mars is. It covers more part of the circle, which is called an arc. It covers a bigger arc than Mars does. So let's see why is that. The Earth does 12 months exactly per year. Mars does 22.6 months of the Earth months for one of its years. That's the reason why the Earth is moving almost twice as fast around the sun as the Mars is. So that's why the Earth covers this much background versus this much arc in here. If I'm on Earth looking at Mars, I'm going to extend from line 1 to line 1. I'm going to see Mars somewhere in here, position 1. If the Earth moves and Mars moves, then I'm in position 2 and Mars is in position 2, so I'm going to draw a line. So Mars initially appeared in position 1. Now it looks like it's in a position 2, moved in here. So it moved in the right direction still. From position 3 to position 3, it has moved in here. So 1, 2, and 3, it moves like everybody else. Looks like it's no problem. 4, it looks like projection in here somewhere near 3. 5, it has moved backward. 6, it has moved even backward. 7, it started to move forward again. And 8 is moving forward, and 9 now is moving in this direction. So this too explains the retrograde motion of Mars. But this explains all the things that are not included in this project. So this is the heliocentric model, where the sun is the center of the solar system. Whereas this is the geocentric model. Both of them explain the retrograde motion of Mars, but there are other things they don't explain. When we come back later on and go in detail, we're going to talk about these things in here. And what is the opposition, which is the conjunction, the inferior and the superior conjunctions, and the regular conjunction, and so on and so forth. And it's all with respect to the Earth and its position versus the sun, what the object we're looking at is. Okay. This led to a very important formula, actually, but you need to apply, you need to use when we're doing calculations. So at this point, I'm just going to talk briefly about this formula. And down the road, we're going to get into details so that we get all of these things done right. Okay. So the Earth year is 12 months. Mercury does it slightly less than 3 months, because 2.89 months is almost 3 months. Venus does it in about 7 months and something. So every 7 months on Earth, Venus will go once on the around the sun. It's a full year on Venus. Okay, we are in the month of September. Toward the end of September, toward the end of February, Venus was in the same position as it was in now, because it went complete cycle around the sun. Okay, Mars takes 22.6 years. 22.6 months. Sorry about that. Okay, that's almost 2 years. Well, Ceres does it in 55.2. That's almost 5 years. 5 years minus 5 months, basically. 4 years and 7 months to go once around the sun, as the Earth does, goes 4 years, 7 months. Jupiter does it more than 12 years, because 142 months, and Saturn's 356 months. Don't talk to me about it. If I use this formula, T here and here are these numbers: 2.89, 7.38, not 12. Okay, 22.6, 55.2, and 442 and 356, because I'm supposed to plug in numbers in here in the table. Okay, except where you see this dark line in here, you're not supposed to touch it. So what I do in this case is TE is 12. So this is 12. If I do Mercury times 2.89 divided by 12, that's the Earth period, minus 2.89. Whatever I end up from here, I'm going to plug it in here. Then I move to Venus. I do 12 times 7.38 divided by 12 minus 7.38. Whatever I get, I plug it in here. Now here it gets a little bit funny. For Mars, I take 12 times 22.6. There is no problem with that. I will calculate, it will give me a number, divided by 12 minus 22.6. The calculator should give me negative 10.6. The bars in here, these two bars, which are called the absolute value, they tell you ignore the negative sign. Just do 12 times 22.6 divided by 10.6. Okay? And you plug in the number in here. And same thing for Ceres, it's going to be a negative number, because it's going to be 12 times 55.2 divided by 12 minus 55.2, ignore the negative sign. That's what these things are. Once you find the months in here, you add them to this, and you're going to find, you tell me when is the next time this thing is going to happen. This formula is based on the heliocentric model, and you can use it to make predictions. When is the next time such and such is going to be in retrograde motion? That's the power of a theory. This one does not work. This one works because you can make predictions. That's what you're going to actually do. You're going to predict when it's going to happen next. Obviously, this requires more work. I promise that we're going to revisit it again after the exam in more detail so that you're at ease with it. So let me go back to the student view, and let me go back home, and let me look at the projects in here. Okay, you will have 2 more projects. One of them has to do with the stellarium, okay, and another one that has to do with the lunar observations, okay. The lunar observation is a must project that you have to complete. There is no choice in that. It's mandatory. This project is optional with another project with the stellarium. Either or, you cannot skip both of them. Either you do the stellarium project or you do the retrograde motion of the Mars. So those are, I mean, you're going to be obligated to submit one of them. If you skip both of them, you're going to receive no mark on this. But if you submit one of them, it's going to suffice. Okay, so that's basically what the idea is. The lunar project is not up, that is actually required. Okay, so this is the other types of assignments. Remember, projects are part of your overall grade too. Okay, can you guys hear me or not?
Yes, I can still hear you.
I'm sorry, I don't know what happened in here, it's frozen. Did I get toward the end of the project or not?
You talked about the second option for the project, but you didn't really go into detail yet.
No, okay, I was not supposed to go into any details in here. For some reason, my camera is not showing. I think that's enough for today in terms of talking about the projects, in terms about other assignments, and in terms of the main thing is actually the exam, and we got that out of the way. And the second one is actually the unit 39. And this project, we're coming back to it anyway, and we're going to talk more in detail about them in the future. So I'm glad that I covered everything about the project, except when we came talking about the second options and things like that. Okay. So I'm going to stop this one before it gets any further deteriorated so that we have at least good enough stuff in here for the materials. And I'm going to go through the recording to make sure any private information you were talking about when this frozen is removed. Okay. Sounds good? Yes, no? Okay, got it. Very good. Thank you very much. I'm gonna stop the recording first.